faster than the space-time fabric itself, by itself, it has the capacity to remain aware of it. Consequently, it will gradually eliminate this idea, filling me with a growing sense of discomfort. At this very moment, the night sky is undergoing rapid transformation. In the coming decades, perhaps even earlier, it could become entirely unrecognizable. Leading experts, including Neil deGrasse Tyson, have raised the stakes, acknowledging the inevitable changes caused by the shifting position of Polaris. The changes behind this phenomenon are surprisingly unexpected. Polaris, also referred to as the North Star, has been a dependable feature in the sky for millennia, an essential reference point for astronomers, navigators, and stargazers alike. However, this may soon be altered, modifying our perception of the heavens and the method by which we investigate the universe. Let's delve into the implications of this alteration. For centuries, Polaris has been a guiding beacon for sailors and astronomers, remaining steadfast in the sky. Its constant presence has been essential for navigation. But that stability may soon be disturbed. In a paper released by the prestigious Royal Astronomical Society in September 2023, alarms were raised regarding the future of this celestial marker. Polaris is about to enter a tumultuous phase, one where it might burst and radically disappear forever from view, altering the sky we are familiar with. Taking into account the potential outcomes, let's take a closer look at this event and the features of the star as a whole. Polaris stands out due to its position close to the North Pole of the universe, directly above Earth's northernmost point. In the sky, it appears almost still. It is a member of the Ursa Minor constellation, often referred to as the Little Dipper. Polaris emits a moderate brightness and is categorized as a yellow-white supergiant. It is significantly larger and brighter than our Sun. Polaris is more than just a single star. It's a component of an intricate triple star system, composed of Polaris A and Polaris B, a pair of binary stars orbiting a third star. The gravitational interactions between these stars influence their orbits and actions, and any changes in these interactions may result in shifts in their patterns of brightness or pulsation. Despite this, the exact nature of these forces remains poorly understood. Polaris is about 323 light-years away from Earth, meaning that the light we observe today began its journey a long time ago. If Polaris were to explode, the effects would not be visible to us for over 300 years. It's even possible that Polaris has already exploded, but we haven't yet seen the results. Throughout history, the North Star has held profound cultural, navigational, and symbolic significance. Because of its unchanging position in the sky, it became an invaluable guide for ancient sailors navigating vast seas and lands. Symbolically, Polaris has represented stability and direction, remaining constant in an ever-changing sky. For astronomers, Polaris has served as a crucial reference point in the study of stellar movements and variable stars. As a Cepheid variable star, its brightness shifts on a regular basis. These shifts have provided important insights into the properties of stars and the behavior of variable stars. This trait has also been crucial for determining cosmic distances and calibrating scientific instruments. Its pulsation pattern has historically been easy to predict, but recently, Polaris has begun to exhibit signs of departing from its usual behavior. This irregularity in its pulsation cycle has caught the attention of astronomers, triggering additional research into the reasons behind these unexpected changes. Rather than following its typical rhythm, Polaris is beginning to behave erratically and dim, raising concerns that the star may be getting close to the end of its lifespan. This behavior follows established patterns seen in stars nearing their final stages. The gradual increase in Polaris's pulsation period, which was once steady, has been traced back to interactions within its star system. In the previous year, there was an annual increase of approximately 4.5 seconds in the pulsation period. While this might appear insignificant, it holds considerable implications. Some astronomers propose that the gravitational forces between the stars within the Polaris system are driving these modifications, directly affecting its atmospheric conditions and pulsation patterns. Others are more concerned that Polaris is entering a critical phase that could lead to an explosion. The similarities between Polaris behavior and that of Betelgeuse, a well-known star in the Orion constellation, are striking. Both stars have displayed complex changes in brightness that have led to concerns they might be on the verge of a catastrophic explosion. Stars nearing the end of life frequently show such anomalies prior to their demise. NASA has expressed greater concern about Betelgeuse and has given it formal attention, but Polaris is now drawing similar focus. As a Cepheid variable star nearing the end of its life, Polaris goes through several stages, including the red giant phase, before ultimately ending in a supernova explosion. Given the irregular pulsations observed in Polaris, scientists predict that it has entered the phase of helium exhaustion, which is typical for giant stars nearing the end of their lives. These irregularities align with patterns seen in other stars approaching their final stages. However, solid evidence of an impending supernova remains uncertain. Astronomers continue to monitor these anomalies to better understand the fate of Polaris. In the event that it undergoes a supernova explosion, it would be a remarkable event in the sky, potentially outshining the moon and appearing for days, weeks, or even months. Its brilliance could alter our view of key constellations like Ursa Major or the Big Dipper, where Polaris holds importance. Fortunately, Earth would likely remain safe regardless of whether Polaris explodes, due to its great distance from us. While the explosion of Polaris might not be as visually stunning as that of Betelgeuse, it could still be visible to the naked eye for an extended period, outshining nearby stars and undoubtedly becoming the focus of astronomers' attention and global observatories. Despite this, the impact on Earth's ecosystems or environment would be far less significant than a supernova occurring closer to our planet. Now, let's concentrate on what will transpire with Polaris itself. What is its future following a potential supernova explosion? Understanding this is essential. While massive stars generally end their lives in a supernova, this is unlikely for Polaris. When a large star undergoes a supernova, its core collapses, triggering a violent shock wave that makes the star disintegrate. However, Polaris is not massive enough for such a dramatic end. Instead, once it has exhausted its nuclear fuel, it will shed its outer layers and become a white dwarf. This transition will not result in a supernova but will mark a quieter conclusion. Polaris will evolve into a tiny, extremely dense stellar remnant. A white dwarf is the compact core of a low to medium-mass star that has lost all its nuclear fuel. Despite its small size, roughly that of Earth, it will still contain the mass of the Sun.